Hi, I'm Victoria Brooks and I'm a veterinary epidemiologist. In a previous video, we looked at the positive predictive value of our test result, our positive test result here, given that our test characteristics, our sensitivity and specificity were 75% and 95%, and our pre-test probability was 60%. Now, in that situation, we found that our positive predictive value was 96%. So we'd gone from thinking that we might have a 60% chance of disease in our animal to thinking, okay, it's 96% given the positive results of this test. Now, test characteristics don't usually change as long as the test is used in a similar population in similar circumstances. However, the prevalence of disease or a pre-test probability that an animal has disease can change. So, for example, let's just imagine that our pre-test probability of disease is now much lower. So perhaps this is a disease for which the usual prevalence is just generally quite low, or the individual animal doesn't really have the clinical signs, all of the clinical signs that we might expect with this disease. So we're only around about 10% sure, or giving a 10% probability that this animal might have disease. So we're going to use this test and see now, and again, we get a positive test result. Okay, so what is the probability that that test result indicates that the animal is diseased, given that we've got this positive test? So let's now go back to our tree diagram or our algorithm, and let's calculate out the different probabilities. Now, the only bit that's changed are the animal characteristics here, or the population characteristics. Let's write that down here. Population characteristics. So previously we had 0.6 up here, but this time we've only got 0.1. And our 1 minus prevalence, 1 minus 0.1 is 0.9. So let's have a look at how this works out. So positive predictive value equals true positives divided by all of the ways in which an animal can be positive, given that we've got a positive test result. So true positive plus false positives. And let's multiply out our arms. So true positives, we've got 0.1 multiplied by 0.75, 0.1 multiplied by 0.75, divided, again, 0.1 times 0.75, plus, and the bottom arm down here, 0.9 multiplied by 0.05, 0.9 multiplied by 0.05. So the top bit's okay. 0.1 times 0.75 is 0.075 divided by 0.075 plus, let's get the calculator for that bit, 0.9 times 0.05 equals 0.45. So 0.075 divided by, let's add up this bottom row, that's 0.12, 0.075 divided by 0.12 equals 60.625, or 62.5%. So see how now, given our lower pre-test probability, we also have a lower positive predictive value, but we can say that given our pre-test probability of 10%, we're now approximately about 62.5% certain that our animal has a disease, given that we have a positive test result.